Hello, thank you for joining me today. We are talking about single replacement reactions and metal reactivity. So goals for today is I want you to be able to complete single replacement reactions and determine your products there. And then on top of that, you're going to tell me whether or not a reaction will actually occur based on the metal reactivity list. And so here we go. So single replacement reactions happen when you get a single element reacting with a compound. For example, we have in this case, a metal reacting with a compound A and Z, and you'll notice that the thing that happens is this A and this M switch places. So A comes by itself, M bonds to Z. This is the case when you have metals reacting, but you can also have halogens and nonmetals, as shown over here. Whoops, that was a horrible circle. But you get the gist. You can also have nonmetals here that can react as well. And so we're going to talk about why and how this works and what we need to look for. Okay, but down on the bottom, you will see this reaction of aluminum and iron 2 sulfate reacting. So we have aluminum here is a solid reacting with iron 2 sulfate. So come on, pen. Right there to produce on this side aluminum sulfate and aluminum sulfate here and iron. Okay, and it's balanced out. Now, what happened was aluminum and iron switched locations. And if we want to know, so that's what happened. So now my question is, what if instead of aluminum reacting with iron 2 sulfate, what if I had iron as a solid reacting with aluminum sulfate? Is this going to produce, because if this goes, we have aluminum and iron are going to switch, so we'll then get, we'll call it iron 3 sulfate this time, just for the sake of doing something different, and aluminum. Okay, and it leaves it balanced almost and works really nice. So we balance it out, we'll put a 2 here, and we'll put a 2 here. Okay. Now, if this is the case, then whenever we get this to take place, we're going to produce this stuff, and then it's immediately going to react again, which would essentially mean that we never get any products. It's just a continual back and forth reaction, and we couldn't actually use it for anything or figure out what's going to happen next because it's just going to keep going. So instead, the way this works, and the reason that aluminum is able to react with iron 2 sulfate is that there is a list of metal reactivities. And we saw this in lab. And so more reactive metals will take the place of and bond to the nonmetals and replace non-reactive or less reactive metals. And so you'll be given a list, this activity series here, and you need to find both elements that are present. So we have aluminum right here, and we have iron right here. Okay? And so I like to think of this as like a big brother, little brother situation, or a big sister, little sister situation. The one that's higher on the list, you see up to the side here, higher on the list is most reactive. Okay? And so I think of this as like a big brother, big sister. If you and your big brother or you and your big sister are sharing something or you get something and you want it, but they are bigger than you, chances are you don't get it. However, if you're using whatever it is, let's say you're playing your Xbox or your PlayStation 5 or PlayStation whatever number we're up to now, and they want to play, they come in and they kick you out because they're bigger. Hey, elements work the same way. So because aluminum is higher than iron is, because aluminum over here is higher than iron, it's going to be more reactive. It's going to kick out the iron from this bond. So because aluminum is more reactive, it's going to kick out this iron atom, as iron ion at the time, and it's going to replace it with itself and become aluminum sulfate, which leaves iron to be formed on its own. So in lab, you saw copper form, especially around the nail made of iron. You saw copper and iron do this. Copper and iron. We reacted iron with copper 2 sulfate. The reaction we did was iron metal reacted with copper 2, I believe it was sulfate, to produce, and on this side they reacted, and we saw, we'll call it iron 2 sulfate form for the sake of simplicity. And you saw copper build up on this iron. It looks like rust because it's nice and bronze colored. or brown colored, and that's copper. So that's exactly what you saw in lab. Okay, so now here's some chances for you to do some look at it. Okay, so will these recur? And so you should have a metal reactivities list in front of you, and your job is to figure out which one's higher, which one's lower. So we're looking at silver, and we're looking at copper right now. So this is silver and this is copper. All I want to know is, does the reaction happen? So if we go back, we see copper is here, silver is below copper. So if silver is below and it's by itself, no reaction is going to happen. You can write NR. Whoops. RNNR. No reaction. Okay, the next one is iron and copper 2 nitrate. This will be the same situation I just demoed on the last one. So this is going to happen. So you can say reaction or will happen. If you want to, you can write the products, which is probably what we should do as a means of practice. So when we do this, we get products will be, we'll call it iron 2 nitrate, just so everything's the same. Okay, so we're going to be there, and then you'd have to balance if it was different. So let's make it iron 3, and then we'll balance it just to practice. So iron 3 nitrate, I have 2 on this side and 3 on the other side. Whoops. So I have, whoops, all sorts of discombobulated. I need 3 here, and I'll put a 2 on this side, so my nitrates are balanced. I need 3 coppers over here, and I need 2 irons here. Okay, so have you tried the next 3? You don't have to necessarily do the reaction part. Tell me if the reaction happens or not. You should pause the video. When you hit play, I'm going to show you the answers. All right, so we had no reaction on the first one. The second one, we did the reaction. We showed it to you. These guys, zinc and sodium. Sodium, the alkali metals are super high up, super reactive. So this one's not going to be kicked out. It's going to stay. There's no reaction there. Lead and aluminum, same kind of thing. Lead is very unreactive. Aluminum is pretty reactive, so no reaction here. And the last one is magnesium and silver. So you saw silver at the top is towards the bottom. Magnesium is above that, so you're going to get your reaction. You can write it out there. Okay? This is metal reactivities, metal activities. So you will have practice on this. If you have questions, let me know. Here's a couple review questions. How do you know if a single replacement reaction will take place? And then, will a reaction take place between aluminum and copper 2 sulfate? So you need aluminum and copper 2 sulfate. And you can go back and use the metal reactivity series earlier in the slide, or you can use the one that's been provided for you. But try those out. If you have questions on this, please, please, please ask. Otherwise, I will see you next time for our next lesson. Thank you very much and have a great day.